Today we're going to look at forces and motion. So a push or pull exerted on an object such as this billiards ball. If I want to make this move, I have to add a force to it. Same thing, if I want to take something like a wagon and pull it, I have to apply a force to that. So a force is a push or pull that is exerted on an object. And when you take all of the forces that are acting on an object and you add them up, like me pushing this way and me pushing that way, you add up all those forces, you come up with the sum of the individual forces, or the net force. When we're reporting units of force, the scientific unit of measurement that we are going to use for describing force is called a Newton. And the symbol is a capital N. And Newtons, a Newton broken down is a kilogram meter per second squared. What this means is if you have a 1 kilogram object and you accelerate it at a rate of 1 meter per second squared, that is applying a force of 1 Newton to that object. So here, these blue arrows are going to represent forces going to the right. If this force and this force are both pushing an object to the right, the net force is larger and still pointing to the right. Because these forces do not cancel each other out, they are considered unbalanced. And the movement of this object is to the right. For these two forces here, the force going to the right is smaller than the force going to the left. So therefore, the net force here, or the combination of all of the forces acting on this object, the net force is going to the left, and this again is an unbalanced force. In the movement, that object is going to the left. For this third example, this arrow is pointing to the right, and this equal force is pointing to the left. Because those two forces cancel each other out, we have a net force equal to 0, and these forces are balanced. So there is no movement. Definition-wise, the definition of an unbalanced force is a non-zero net force which changes an object's motion. And balanced forces, such as these, they're not zero forces, they are two forces canceling each other out, so they have to be equal forces acting on an object in opposite directions, and the result is there is no change in motion.